The easiest way to do poker hands, especially where you want to get the total possibilities of poker hands, is we're going to start out with the highest value of a poker hand. A poker hand has 5 cards, and there's a straight flush, 5 cards in sequence of the same suit, 4 of a kind, full house, 3 card, etc., etc. As we go through them, you'll get a better feel for them. So in order to calculate A, we are going to total B2 I, right? And to calculate A, we'll go total possibilities. Oh, yes, of course, I apologize. My screen has gone blank. Okay, total possibilities minus sum of B2I. Okay, so that's the way we're going to do it. Because these all have a value, these have no value at all. So a deck of cards has 52 cards, okay? So in a deck of cards, we have ace can be considered low or high. So I'm including ace can be low or high. Ace could be a 1, higher than a king. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, when we speak of a suit, we are a suit, there's 4 suits, right? And those are heart, diamond are the red cards, right? Clubs and spades. That looks something like that. Okay, there's 4 suits. And then when they talk about face values, they're talking about this. These are all our face values. So there are 4 cards of each. There's 4 aces, 4 kings, 4 queens, 4 jacks, all the way down to 4 twos. This can be treated as a 1, or it can be treated as the highest card. Alright, so let's look at this. A straight flush, okay, we have 5 cards of sequence of the same suit. Did you have any questions so far? Okay, 5 cards a sequence of the same suit. So let's see where these sequences can start. So 1, 2, 3, 4, 5. It could start with the 10, right? You could get 1 straight here. 1, 2, 3, 4, 5. So that's one place it could start. It could be 9, 10, jack, queen, king. It could start at the 9. It could start at the 8, all the way down to the ace. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to pick the starting position. So out of the 10 choices, we're going to pick 1. Right? Because you could have an example of a straight would be 1, 2, 3, 4, 5. Ace, 2, they could start there. You could have that one, or that one, or that one, or that one. Now it's all of the same suit. So how many choices in the suits do we have?
4.
So there are in total 40 straight flushes. Make sense? Can you see that? Because you could have an ace, 2, 3, 4, 5 of hearts. You could have it of diamonds. You could have it of clubs. You could have it of spades. Good? Make sense? Okay, now let's look at four of a kind. Four cards of one face value and one other card. Okay, how many ways can we get four cards of one face value? Huh? 13 different ways. So 13, choose one, because we could either have four aces or fours or four eights or four jacks or four kings. Now, once we pick that card, we need out of the sevens, we have to pick all four suits. Agreed? There's four suits, so if I pick 8, I need all four of the four suits, right? How many cards do I have left over to get one more card? Huh? And but there's 48 cards left. You can do that too. Or you can do 13, choose one, 4, choose 4. Yeah, or you could do 12, choose one times 4, choose one. These three things is equivalent to those four things. Right? 13, choose. Yeah, but 12 times 4 is 48. Whatever makes more sense to you. Either one, this one equals 640. 624, you're right, 624. Now, can I explain that any better? Yes. Why is it? Okay, there are 13 face values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we want either 4 2s or 4 3s or 4, so there's 13 choices here. 13, choose one. And once we have the 4, we want 4 of the 4 cards, right? Because each 4 has 4 suits. This should equal 624. So far, so good? Now, we want 3 cards of one face value and 2 cards of another. Anyone want to give it a try? Yes. Perfect. Perfect. So that equals 3744. Crazy, eh? Let's not complicate it just yet. Let's keep it at 5 right now. Yeah, poker has 5. Yeah. Yeah. Okay. How are we going to do this? 5 cards of the same suit, but not in sequence. 5 cards of the same suit, but not in sequence. Perfect. So, oh, I wonder why. Perfect. Subtract the straight flush. Because you could get the straight flush here, and we don't want to do that. Right? So subtract straight flush. Why is it interesting? Can I explain anything? You choose your face value. You choose the suit. In this case, they chose hearts, but they could have chose spades or clubs. And then, now that we've chosen our 5 cards, right, we have to subtract the straight flush because we could include it in here. It would be double counted, right? We have our straight flushes here. Here we want anything but a straight flush because it's already counted here. Anyone want to try the next one? 5 cards in sequence, but not the same suit. Four, choose one. You have to choose. And could this include the straight? This works out to be 10,200. Anyone want to try the next one? 3 of a kind. Because you want 3 of a kind, right? And 2. But when you do it like that, you're putting in an order. Go 12, choose 2, get your 2 other cards, right? What? Right. So we have our 2 other cards, but now we have to pick the suits of those 2 cards. 4, choose 1 individually. I don't know where you're getting 49, choose 2 from. Well, you could, but you could end up with, if you do 49, choose 2, you could end up with a pair. We're trying not to get a pair, right? Because a full house has the pair. So this works out to be 2 pairs. Which are you talking about, C? Oh, 12 choose 1, 11 choose 1? Yeah, but you're introducing an order. When you go 12, choose one, then 11, choose one, you're starting, you want your two cards. You're starting a permutation. Can you guys help me on C? Yes. And then you want to go 12, choose, you want two pairs. You're, tell me what's next in your plan. Yes? See how when you split it up, you're introducing an order? The idea is you need two pairs. So you have 13 face values. Select whatever you want a pair of. Because the way you're doing it, you're choosing one pair before the other pair. And you don't want that. Because you're introducing an order. Yeah. You need two 4 choose 2s. One for each pair. And then what? Not 48. You already have 4 cards. Yeah. You need to pick a different card. You don't want to pick one of these cards, right? If you could pick another 5 if you choose from 48. Yes. The straight flush? Oh. Hold it a sec. There's for 3 of a kind, you might be because we took care of that. The full house is a triple and a pair, right? And here, 3 of a kind, we have individual. We won't get 2 pairs here because of the way we set it up. So I don't think we finished C. C is, what's missing? 4, 1. 4, choose 1. One pair, what do you think?
13 choose 1, 4 choose 2, 12 choose 3, 4 choose 1, 4 choose 1, 4 choose 1.
Perfect. This is equal to 10, 98, 240. Okay, what we're going to do is take total possibilities minus the sum of. There is a single step you do, but I for A, but I can't wrap my head around it. But I will give it to you. The sum of A to I is 1,296,402. The sum of B to I is this. So total possibilities, you have 52 cards, choose 5 of them, minus 1,296,420 is equal to 1,302,540. 1,302,540.
So you guys have a 50% chance of getting a special hand, right?
What's 52 choose 5?
Well, the sum of those two, and they're pretty much evenly.
Yeah, you're right.
Almost 50%.
Yeah.
time a card is dealt, your chances of getting a special thing either decreases or increases depending on what card was dealt.
But if you're not playing against people, if you're just choosing 5 random cards from that deck,
Yeah, when you're just choosing, but when you're
When you're alone.
almost a 50% chance.
Yeah.
No less.
Now this is the formula. This is the formula for A. If you can make sense out of it, I'll be very impressed. But it's 13 choose 5 minus 10 choose 1. 4 choose 1 to the 5 minus 4 choose 1. That will get you answer to A.
answer to A.
Yeah. It's this difference times that difference.
Destroy any possibility of having a fourth. Okay, so in the second bracket, because you're choosing